Welcome back everyone. This is our CSCA Physics Preparation Series. And if you have not watched episode number first on mechanics, I recommend you go watch that post. The link is in the description. Today we are moving to our next topic, which is electromagnetic, and I will first quickly show you what is covered under this topic and the syllabus, and then we will go straight into my handwritten notes. So let's get started. And today we will cover electromagnetism. This is the main topic, and in electromagnetism we are going to cover electrostatic. In electrostatic, we will cover Coulomb's law, electric field strength, electric potential, and the next subtopic is direct current circuit. And direct current circuit, we will study Ohm's law, series and parallel circuits. And next subtopic is magnetic field, and magnetic field we will study magnetic induction, ampere force, Lorentz force, and the last we will cover the subtopic electromagnetic induction. And electromagnetic induction we will study Faraday law and Lenz law. So let's go to my handwritten notes and cover all these topic clearly. So, and the section number 2, the main heading is electromagnetic, and we will cover the subtopic first, that electrostatic. What is electrostatic? And within electrostatic we will cover Coulomb's law, electric field strength, electric potential. We will cover the importance formulas and importance points and this. Okay, so the first is electrostatic. What is electrostatic? Electrostatics. And electrostatic we will study what the important thing, that is a unit of charge. What is the unit of charge? Is all we know that the unit of charge is coulomb, and it is represented by C. Smallest unit of isolated charge is electron is mm, that the value of electron is 1.6 and to 10 power minus 19 coulomb, and it is the value of smallest unit charge, isolated charge. Smallest isolated charge is electron, and the value of it is 1.6 and to 10 power minus 19 negative 19 coulomb. Okay, what is Coulomb's law and what is an importance that? So in Coulomb law we will study the Coulomb law equation, which is that F is equal to k q1 q2 divided by r square, and here F represent Coulomb force, k represent Coulomb constant, q1 and q2 are the two charges, and r square is the distance between these two charges. Here the k is equal to 9 and to 10 power 9 Newton meter square and to Coulomb square, and the k value is that 1 over 4 and to pi epsilon naught. If we put this value, they will give us this value. So you must memorize this value and also this unit. Okay, now what is electric field strength? Electric field strength is equal to force per unit charge, and we also derived the next formula from the electric field strength, which is that kq divided by r square, and the unit of electric field strength is Newton per coulomb or volt per meter. What is electric potential? Electric potential is the work done per unit charge, which is equal to kq by r. So this is the two formula of electric potential. Now what is the unit of electric potential? The unit of electric potential is volt, where 1 volt is equal to 1 joule per coulomb. Now what is the nature of electric potential? This is the important. The nature of electric potential is scalar, that it is a scalar quantity, mean that it has a magnitude but it is not a specific direction, so it is a scalar quantity. Now we will study a relation between E and V. E is representing electric field and V is representing electric potential. So as we know that work is equal to F into D, and V is equal to work done per unit charge. So And also from this equation we will study that force per unit charge is electric field. Now here this is derived that the relation between that E and V is that V is equal to E into R. Now when we find E, then E will be equal to minus delta V divided negative delta V divided by delta R. This is the relation between E and V. This is the important equation which you must memorize. Now go to the next subtopic, which is direct current circuit, Ohm law, series and parallel circuit. So here it is written that DC. First of all, we will study what is electric current. Electric current is the flow of charge per unit time, and its unit is ampere. What is potential difference? Potential difference unit is volt and resistance unit is ohm. This 2 point you must also memorize. Okay, Ohm law is and the Ohm law said that when there is that voltage is directly proportional and to current while keeping the resistance constant. So from this we derive this equation, which is V is equal to IR. This is the Ohm law equation. You must also memorize it. It is also important. Now what is series circuit? Series circuits in within series circuits there's only one path for the current. This is the important point in the series circuit, and the current must be equal to is equal to I1 is equal to I2, mean that that there is only one path for the flow of current, so the current will be equal. So okay, and voltage, so total voltage will be equal to the sum of the individual voltage. Now what is equivalent resistance? The resistance and the series circuit is that we will sum up the we will sum up the individual resistance, then it will give us the equivalent resistance. Now move to the next. This is what is parallel circuit. What is the parallel circuit? In parallel circuit there is providing of multiple paths for the current. Okay, and at current the total amount of current must be equal to the sum of individual current, and voltage, total voltage will be equal to V1 will be equal to V2, mean that that same amount of voltage will be moving. Now what is equivalent resistance? So equivalent resistance is equal to 1 over R phi is equal to, here R represent resistance and P represented parallel circuit, and here it will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is the equation from which you will find parallel circuit. Now what is power? Power is equal to VI, which is equal to I square into R, and which is equal to V square divided by R. As I said to you that you will use the equation by seeing to the given data. Okay, and if there is more than one formulas per single quantity. So okay, in this lecture I will give you the short notes and formula. If you want the detailed note, then comment it below. Okay, then I will prepare you for a detailed note of it, in which there is definitions, explanations, and the derivation of the formulas. Here I only gave you the formula, not derivation. If you didn't understand it, then comment it, and I will make a video in which I will explain how it is derived. Okay, now we move to the next subtopic, which is the magnetic field, and within magnetic field we will study magnetic induction, ampere force, and Lorentz force. So let's go. Here we will study magnetism. What is magnetism? So stationary charge only, we know that stationary charge only have electric field, and moving charge have both an electric and magnetic field. So this 2 point and magnetism, you should memorize that stationary charge have only electric field, and while moving charge have both an electric and magnetic field. What is magnetic induction? It is either a vector quantity or scalar quantity. So it is a vector quantity because it have a magnitude as well as direction. What is the unit of magnetic induction? Magnetic induction is represented by capital B, and the unit of magnetic induction is Tesla, which is represented by the capital T, or it's also equal to Weber per meter square. What is Lorentz force? The formula of the Lorentz force is that F is equal to Q VB sin theta. Here Q represents charge, V represents speed, electric potential, and B represent magnetic field, and sin theta is the angle between them. So the formula of the Lorentz force is this. What is ampere force, and what is the formula of ampere's force? So magnetic force on a current carrying coil, it is also called magnetic force on a current carrying conductor, okay, and its formula is equal to F is equal to BIL sin theta. Here F represent force, B represent magnetic field, I represent current, L represent the length of the current carrying conductor, and sin theta is the angle between them. Here and the ampere's force and magnetic induction, we also discuss direction rule. So Fleming left hand rule used for forces, okay. The first rule is the Fleming left hand rule, which is used for the force for finding the direction of force. So a thumb will represent force, first finger magnetic field, and second finger current. So this it is the left hand thumb. This is the thumb will represent the force, first finger will represent magnetic field, and the second finger will represent current. So you can memorize it. FBI, F represent force, B represent magnetic field, and I represent current. What is the right hand rule? Right hand palm rule. So the right hand palm rule is that point finger in the direction of magnetic field, okay, thumb in the direction of V or I, the palm will push in the direction of the force, okay. This is the second right hand rule, palm rule. If you memorize this rule, this will also be enough for you. Now move to the next, which is the the last subtopic is that electromagnetic induction, Pareto law and Lenz law. In electromagnetic induction, the important thing is a magnetic flux. So magnetic flux is equal to BA cos theta, and its unit is Weber, and 1 Weber is equal to 1 Tesla and 2 meter square. And here Pareto law of induction say that the equation of Pareto law of induction is that magnetic flux is equal to negative and change in magnetic flux per year time. Here the n represent number of turns, n represent negative sign represent opposite direction, okay. Over here this sign epsilon represent magnetic flux, and here the negative sign is put by the Lenz law, okay. So we covered this. Now here the key formulas and definition that you must memorize that come in CSCA exam. So the first symbol is that, and it is induced EMF. Its meaning is induced EMF, electromagnetic force, and its unit will be the volt. Here this sign is magnetic flux, and its unit is Weber. Here this sign is magnetic flux density, and its unit is Tesla. Here V is velocity of conductor, and here it is unit it's meter per second, and L is the length of conductor, and its unit is meter. So Alright, that is everything for electromagnetism. I hope my notes made it short and easy for you. Episode number 3 is coming very soon, so make sure you are subscribed and bell is on so you don't miss it. If anything was unclear, drop your question in the comments. I read every comment. See you in the next one.